Assalamualaikum warahmatullahi wabarakatuh. Hello everyone. How are you today? I hope all of you are in a good condition. In today's video, I'm going to explain about how to reduce image noises using machine vision. So let's start. Starting from image noises definition. Image noise is a random variation of brightness or color information in an image. It is a degradation in image signal caused by external sources. And in the right side, this is the example of image noises. As you can see right here, this one, and this one is the example of image noises. The quality of image is not quite good because of the noises right here. All of these are the noises. Next, how do we remove or reduce image noises? Okay, we can reduce image noises using machine vision technique, which is blurring or called blurring. What is image blurring technique? Blurring is a technique that is achieved by convolving image with a low-pass kernel. This technique is useful to remove or reduce noises, as you can see right here. This is the example of the implementation of blurring technique. There are 4 types of blurring techniques, which include averaging, Gaussian blurring, median blurring, bilateral filtering. In the next slide, I will explain you guys about these 4 techniques. Okay, starting from averaging. Averaging is an image blurring technique that is done by convolving the image with a normalized box filter. It takes the average of all pixels under kernel area and replaces the central element with this average. Averaging technique is done by the function cv2.blur. As you can see right here, this is the example of averaging technique, just like this. So this previous image is using the averaging technique, just like here. Next is Gaussian blur. Gaussian blur is a type of blurring technique that uses the Gaussian method to do the blurring technique. It is done using the function cv2.Gaussian blur. The Gaussian blur technique is widely used in graphic software such as video editing and many more to reduce image noises or to make blurry image or video. As you can see right here. Median blur is an image blurring technique that computes the median of all pixels under the kernel window, and the central pixel is replaced with the median value. Median blur technique is highly recommended to deal with salt and pepper noise. This is the example of an image that have a salt and pepper noises. Median blur is done using the function cv2.median blur. So this image use median blur to reduce the noises. As you can see right here, it have a better result than this. Next, bilateral filtering. So bilateral filtering is an image blurring technique that is effective in noise removal while still preserve the edges. It is different with the other techniques because they tend to blur the edges. So you can see right here, it still reduce the amount of noises right here. As you can see here, the noise become a little bit smoother than before, but the edges right here, for example in the dark right here, still in the good condition, not really blurred, because on the other technique the edges becomes quite blurred, just like here, quite blurred. In this image also, as you can see right here, the dark faces become a little bit blurry, and this in the tiger is quite blurry also. But for bilateral filtering, yeah, it is quite blurred, but the edges is still a little bit clear. This technique is done by the function cv2.bilateral filter. Okay, in this slide I will explain about the program. This is the averaging program. This line told the program to read the given picture or image and this line is to resize the image become this size, and this line is to show the original image or this file right here. Meanwhile, this is the function for averaging technique. This is the function for averaging technique, and this line told the program to show the result from averaging implementation for this picture. Okay, next is Gaussian blur program. Actually, the program is quite the same with the averaging program, but the difference is only right here in the technique. It's using the cv2.Gaussian blur. It is also the same with median blur program. Still almost the same program, but the difference is it's only on the function right here, cv2.median blur for median blur technique. It's also the same with the bilateral filtering program. The difference is only right here, cv2.bilateral filter for bilateral filtering program. Okay, next is the result from those 4 techniques. So this is the original photo. So for this result, I will show you guys the same image for the 4 different technique to show you guys the difference between those 4 techniques. The result from those techniques. So you can see this is the result from averaging technique. As you can see right here, the noises is quite gone right here. It reduces the noises, becomes a little bit smoother than this one, but the duck face is become a little bit blurry. Meanwhile, this is the Gaussian result. It's almost the same with the averaging technique, but it's not as blurred as this. It's more blurry. The averaging techniques, the result from averaging technique is a little bit blurry than the Gaussian result, as you can see right here. Meanwhile, this is the median result. The median result, it's almost the same with the Gaussian result, but for the median result, the noises is quite smoother than the Gaussian result, as you can see right here. And this is the bilateral result. It's smoother than the other technique, maybe as smooth as averaging technique, but the edges right here, it's clearer than those other 3, as you can see right here. It's clear, and the other 3 is quite blurry, especially this technique. So this is the difference between the 4 techniques. The result is quite different between the 4 techniques. I think the best techniques for blurring is bilateral result, because it blurs the noises, but the edges is still, it's not blurred, still clear here. That is the advantage using bilateral result. Okay, thank you for watching this video. I hope it helps you guys to understand about the image blurring technique. Okay, thank you for watching. Take care and goodbye.